When we talk about linear equations, really the whole purpose of having linear equations isn't just to cause you pain and anguish, it's to help us solve problems. So that's what linear equations are used for. And so in this lesson we are going to talk about different examples where we can use a linear equation. Remember, just linear just means an equation that if you graph it forms a line. But we're going to show how we can use linear equations to help us solve problems. Now, a list here is some problem-solving strategies. We've already kind of worked with using a verbal model and how we can take what we say and put it into algebraic terms. But we can also draw a diagram, which we'll work on today, guess, check, and revise, make a graph, list, or table, which we'll work on some. Another strategy is solve a simpler problem or use a formula. And these aren't all the problem-solving strategies, but they are some of them. And a lot of times we do this stuff without even realizing that we're using a problem-solving strategy. Okay, so let's see how we can use equations to help us solve problems. It says the page of your school yearbook is 8.5 inches by 11 inches. The top margin is 3/4 of an inch and the bottom margin is 1 1/4 inches. The space between the pictures is 3/16 of an inch. How high can each picture be to fit 7 down the length of the page? Whoa, a lot of information there. Normally this is one where we put IDK by. Not this time though, because remember, one of our strategies is to draw a diagram. So let's draw a picture of it. For example, school yearbook. So here's going to be my page in the school yearbook. And it says it's 8.5 by 11. So here's 8.5 by 11 inches. The top margin is 3/4 of an inch. So here's my top margin. Yes, I know, pretty sloppy, but that's going to be 3/4 of an inch. And the bottom margin, to be a little bit bigger, is going to be 1 1/4 of an inch. The space between each picture is 3/16 of an inch, and it wants us to fit 7 pictures. Okay, so they want is to have 1, 2, wow, that's bad, sorry, 3, 4, 5, 6, 7. In fact, we'll make that one a little bit bigger. Okay, so again, I'm just doing a rough diagram here, obviously very rough, of what the yearbook would look like. So we have our 3/4 of an inch for our top margin. We have our 7 pictures, and we have our 1 1/4 margin at the bottom. Now it says the space between the pictures is 3/16. That means between every picture here is 3/16. Okay, each one of these. Okay, and in fact, if I draw this better, okay, we don't need these lines in here because that's where the pictures start. Sorry, taking me so long to erase this line. Anyway, the picture starts where the top margin is. Okay, so we have our diagram here, 3/4 of the top, picture, 3/16, picture, 3/16, so on and so forth, to the bottom here where we get 1 1/4. If we wanted to set up an equation, okay, we know our margin is going to be 3/4, that takes care of this. And then we know we're going to have how many pictures? 1, 2, 3, 4, 5, 6, 7. It tells us 7. So we're going to add 7, but we don't know how high they are. So we'll call that x. Then we're going to have the space between each picture. Now this one can be a little bit tricky because you're going to ask yourself, well, how many spaces are there? Well, there's just 1, 2, 3, 4, 5, 6 spaces between the pictures. So we can add on to that 6 times the space between the pictures, which is 3/16. And then we have our bottom margin, which is 1 1/4. What does that have to equal? Well, how tall is my page? 11. Okay, so do you see how drawing a diagram helps us set up this equation? Now, yes, this can be a little bit tricky because we're dealing with fractions, but we know how to do this. Combine your like terms. In this case, our like terms are 3/4, and then whatever 6 times 3/16 is, and 1 1/4. So let's focus on this right here. If you want to multiply this, 6 doesn't go into 16, but 2 does. 2 goes into 6 3 times. 2 goes into 16 8 times. So this ends up being 9/8. So our like terms are 3/4, 9/8, and 1 1/4. Remember, before we can add, we have to have them all with common denominators and all in the same form. So I'm going to rewrite this as 3/4 plus, we have our 7x, plus 9/8 plus, I'm going to make this into a improper fraction. 4 times 1 is 4, plus 1 is 5/4 equals 11. Now we're getting closer. Now we need a common denominator. If you look here, again, we're not going to focus on our 7x yet because that's not a like term. 4, 8, and 4, well, a common denominator would be 8. So 4 times 2, so 3 times 2 is 6, plus 7x, plus 9/8, plus, again, times 2 times 2, 10/8. Whew. Now we're there. 6 plus 9 is 15, plus 10 is 25/8, plus 7x, that has to equal 11. Now, let's solve. So I'm actually going to copy this and put it on another piece of paper because I'm running out of room. Okay. We're solving for 7x, so we have to get rid of 25/8, so let's subtract 25/8 from each side. That cancels. We're left with 7x equals, well, kind of hard to say again because we need a common denominator, but this can be 11/1. So if we times that by 8 and that by 8, we get 88/8. So 88 minus 25 is going to be 63/8. Alright, so now we divide both sides by 7. That cancels out when we're left with x equals 63/8 divided by 7/1. Why did I write it like that? Well, to help us remember that when we divide by a fraction, we multiply by the reciprocal. Lots of good review in this problem. Drawing a diagram, working with fractions. So now we can cross reduce. 7 goes into itself one time. 7 goes into 63 9 times. 9 times 1 is 9. 8 times 1 is 8. And if we write that as a mixed number, 8 goes into 9 one time, and there's 1/8 left over. So after all of that, how tall can each picture be? 1 1/8 of an inch. Again, that diagram helped us set up our equation, then we had to use our knowledge of fractions to get to our solution.